In this problem, we have a squirting jellyfish, and we are supposed to calculate its oscillation period. In this graph, we have the deflection of the elastic bell. So as you can see, it's a damped, simpler harmonic motion. So the oscillation period is simply the time difference between two consecutive peaks, for example. This is T1 and the second peak occurs at T2. So the period would be T2 minus T1, which is about 0.75 seconds. Effective mass can be found from the relationship of natural frequency, which is omega over k over m, where m is the effective mass. Solving for m, we have v squared or omega squared equals k over m. So m will be k over omega squared. And omega squared is 4 pi squared, frequency squared, and we know that frequency is 1 over period, so we get k times t squared divided by 4 pi squared. The spring constant for the bell was estimated to be 1.2 newtons per meter. Oscillation period is 0.75 seconds. That divided by 4 pi squared gives 0.017 kilograms, which is 17 grams. In part C, the question was, by what factor does the amplitude decrease over one period? So what is A1 over A2? If, for example, A1 is here, and this would be A2. And also, what is the time constant of the damping? So first, let's evaluate A1 over A2. That would be 0.6 centimeters divided by A2, 0.15 centimeters, which is 4. So the amplitude reduces by a factor of 4 over one period. Now, to get into the time constant, we have to calculate the damping constant gamma. This relationship was developed in the video 14.7, so if you didn't watch that, go and have a look. Anyway, we got the following. So the gamma is natural log of the ratio of two consecutive amplitudes, or any two amplitudes, and the time between them. So in our case, ln A1 over A2, we know that this is 4, so we get ln 4. The time between the two peaks, it's just a period, 0.75 seconds. And this gives us 1.85 1 over a second. And the time constant of the decay or damping was found to be 1 over gamma. So we have 1 over 1.85, 1 over a second, which gives about 0.54 seconds. Again, these relationships were developed in video 14.7.